Today we're going to look at dot plots. So these are very similar to box and whisker plots, where they are a visual representation of our data. One thing that is different about these is I can figure out the mode and I can figure out the mean from a dot plot. With the box and whisker plot yesterday, all you could see was the median, the middle of the data. You could see the lower half of the data and the upper half and the max and min, but you could not figure out the mean or the mode. So with a dot plot, this particular one that's on the screen would be symmetrical. So notice that it is the same on the left as it is on the right. Down here at the bottom in blue, I have the median, and then behind it in red, I have the mean. So what I want you to notice is when I move the dots. So if I were to take one of these dots over here and move it, notice that the red down at the very bottom is moving. That is the mean. So as I move it, let me move the screen over. As I move it further, the mean is going to get higher, okay, as I move this to make it an outlier. And then I move it back and it's fine. The median, notice, did not change. It's still in blue. It's still right there in the middle. But if I were to add more dots to the right-hand side, you can see that the mean is moving, but the median is also moving because I'm adding more dots to the right. Okay. The way that we read these is if I'm looking at survey data and this is my dot plot, and let's say I'm looking at the numbers of hours spent working on homework each week. Then over here where it says 1 and there are 2 dots, that would mean that 2 people said that they only work an hour each week on classwork or on homework. So 2 people said 1. So that's right there. Then I have 2. So 3 people said 2 hours. And then the next one is 3 also. So 3 people also said 3 hours. And then 4 means that 4 people read or worked 4 hours. And so that's how you would read that. Okay, so let's look at your note sheet. Called Measures of Variability dot plots. And let's do these questions together. Okay, so we have a dot plot. It says minutes to eat breakfast. What information can you gather from the dot plot? So let's say that I ask my homeroom, how long it takes to eat breakfast. So you can see here I have 1, 2, 3, 4, 5, 6 people said 0 minutes. So they did not eat breakfast. And so then you can see that this is 2 people said it only takes them a minute. So that's how you would read that. So number 1 says, what is the mean of the data set? So I need to figure out the mean. I would count up how many dots total, and there are 40 dots. And then what I would do is I would just write on top how many people said that. So 2 people said 1, and then I have 3 people that said 2 minutes. So that's 6 minutes total. I have 1, 2, 3, 4, 5 people who said 3, so that's 15 minutes total. I get 2 people said 4, so that's 8. I have five people that said 5, so that's 25. 2 people said 8, so that's 16 minutes. Then we have 27. We have then 70 minutes, 44 minutes, and then just one person that said 12 minutes. So then I would add up all of those numbers. And I would get 225 minutes, divide that by 40, and I get 5.625. So on average, it takes those kids in homeroom about 5 minutes to eat breakfast. Okay, to find the median, I would need to count over until I get to the middle. Well, if I know that 40 people were surveyed, then the middle would be 20 dots in. So I would just start and cross off 20 dots until you get to the middle. Okay, so that means the median is right here, so the median would be 5. Okay, number 3, how many students take 10 or more minutes to eat breakfast? So I'm going to look right here at 10 or more. And so count up how many dots. So 1, 2. So there's 12 people. Number 4, is the mode or mean greater? And by how much? So it's very easy for us to see what the mode is on a dot plot because I'm just going to look for the tallest amount of dots, or like the tallest tower, which would be right here. So that's the mode. We already found the mean was 5.625. So take 10 minus 5.625. And that will tell me how much, by how much it is. So 10 minus 5.625 is going to be 4.375. If the next student survey said it takes 15 minutes to eat breakfast, which measure of central tendency would it affect the most? Explain your answer. So the mode would still be the same. So if I add a dot over on the right-hand side at 15, the mode's still going to be 10. That has the most dots. The median is at 5, and it would just move it over 1 dot, which would still be 5. So the mean is affected the most. Because the other two are not affected at all. All right, let's look at practice 1. So the Box and Whisker plot shows the number of runs scored by the teams last season. Which team is more consistent in the number of runs they typically score, and explain. So on the rest of the sheet, we're going to have more review of Box and Whisker and the dot plots. So which team is more consistent? That means that their box is more tightly packed together. It's not spread out all over the place. So the Brewers would be more consistent because their data is closer together. 1B, what is the difference in the interquartile ranges for the Brewers and the Tigers? So remember the interquartile range is going to be from one side of the box to the other. So for the Brewers, that would be 32 minus 29, which would be 2. And then for the Tigers, we got 26 and 33. So 33 minus 26 would be 7. So 7 minus 2 equals 5. So the interquartile range between the two has a difference of 5. Practice 2, the box and whisker plot shows the number of hours 2 dancers practice each week over the last few months. 2A, how much more of Rachel's data falls between 2 and 20 than Tiana's data? So looking at Rachel's, here is 2, and then here is 20. So remember that each section of the box and whisker plot is 25% of the data. So 25% of the data falls from 2 to 10, another 25 here, and then another 25 here. So that means that 75% of Rachel's data is between those two. And then Tiana's, so 2 is here, and then 20. So you can see that this is only 2 sections of the box and whisker plot. So that'd be 50% for Tiana's. So take 75 minus 50 gives us that Rachel has 25% more than Tiana's data. To be, who would you expect to be a better dancer, and explain? So if you look at the data, Rachel's is closer together, whereas Tiana's is all spread apart. If you look at just Rachel's top 75% of her data, it is 10 hours or more a week. Whereas Tiana's has over 25% of her data is going to be less than that. So we're going to say that Rachel would be expected to be the better dancer because she is more consistent. So practice 3, the two dot plots below show the number 2 girls practiced. What is the difference in Lily and Alessandra's average time practicing? So with both of these dot plots being symmetrical, just like in the animation I showed you in the beginning, the mean and median are both right here in the middle. So this is 60, and then the same thing for the other girls, that's 50 right here. So 60 minus 50 would be 10. If those were not symmetrical, then I'm going to have to actually calculate the mean and add up all the dots and then divide by how many dots there are. Whose data shows more variability? So yesterday we talked about consistency. So if something is more consistent, then their data is closer together. If it's less consistent, it is more spread out. Variability is going to be the opposite. So if I have something that's more consistent, then it is less varied or has less variability. If I have something that's less consistent, then it is more varied. So with the way this data is for both girls, they are spread out the same amount. Their dot plot looks exactly the same. So we're going to say that they are the same variability. Okay, practice number 4. The dot plot shows the weight of house cats and small dogs in pounds. On average, do house cats or small dogs weigh more? Justify your answer. I can see that the house cats are more to the right than the small dogs. So the lowest is right here, which is the middle of the small dogs. So we're going to say that house cats weigh more. Because their data is more to the right. Okay, for B, how many more dogs are represented in the dot plot than the house cats? So I'm looking at the number of dots. So there are 9 dots total here for house cats. And then there's 11 for small dogs. So 11 minus 9 would be 2. Practice 5, the dot plots show the test scores for 2 different tests. What is the difference in the mean of test 1 and test 2? So that means that I would have to add up all the dots. So I would do like 55 plus, then I have 275, so that would be 150 points. Then I have an 80. Then I have 385s, which would be 255, and so on. So I would add up all of those, divide by how many dots. And so for the first test, I get that the average is 87.5. And then I'm going to add up all of the ones for test 2, and I get that that is 88.75. So 88.75 minus 87.5 would be 1.25. In test 1, there is an outlier, so that outlier is at 55. If that score was removed, what measure of central tendency would be most affected? So the mode would still be the same. I would still have my highest amount at 100, so mode is not going to be affected. The median, when I remove an outlier, may move over 1 dot, but it may not even change numbers. It just will shift barely. So the mean is the most affected when we have an outlier. Practice 6, the Box and Whisker plot shows the average monthly temperature of 2 cities. What percent of Phoenix's data falls between 66 and 86 degrees? So 66 is right here. 86 is right here. Remember, each segment of the Box and Whisker plot is 25% of the data. So that means we've got 25% and another 25%. So that is 50%. And then the last one, 6B, what is the difference in the 2 cities' medians? So we have 79.5 and 86. And subtract, and you get 6.5. For the rest of the class period, take out a device and finish the next set of problems in the class kit from yesterday. You will have a quiz tomorrow, but you are allowed to use your notes or the class kit in order to complete that.